A circle is defined as a closed shape whose outwards boundary is equidistant or equally distant from the center. This distance is known as the radius, and 2 times that distance is known as a diameter. The outwards boundary referenced before is known as the circumference. The space inside is the area. We also have tangent lines, which touch the circle at 1 point, secant lines, which cut through the circle at 2 points, and chords, which connect 2 points but do not go through the circle. We also have pi, an irrational constant that probably won't be memorized. It's a ratio that's equal to 3.141599265, and so on. If pi is equal to the circumference c over diameter d, we can multiply d to both sides to get the diameter times pi to equal the circumference. Recall that the diameter is equal to 2 times the radius, so we can rewrite this equation as 2 times pi times the radius is equal to the circumference. We'll utilize this in a bit, but first let's review a bit of trigonometry, or the study of angles and their relationships to shapes. Let's take an equilateral triangle with a side length of 2. If we cut a line straight down the middle, we can make ourselves a 30, 60, 90 triangle. Using the Pythagorean theorem, with side length of 1 and hypotenuse 2, we can solve for b. 1 squared plus b squared is equal to 2 squared, where c is our hypotenuse 2 and a is the bottom side 1. 1 plus b squared is equal to 4, and b squared is equal to 3. If we take the square root of both sides, we get b is equal to the square root of 3. If you recall from geometry, we can use multiple ratios to represent the relationships of angles to sides. Sine of an angle, for example, is the ratio of the opposite side to the hypotenuse. Sine of 60 degrees is the square root of 3 over 2, since the square root of 3 is on the opposite side to 60 degrees and 2 is our hypotenuse. Following this logic, sine of 30 degrees is 1 over 2, or 1/2. Cosine is the relationship between the adjacent, or touching side to the hypotenuse. Thus, cosine of 60 is equal to 1 over 2, and cosine of 30 is equal to square root of 3 over 2. Now, let's look at a different case. A 45, 45, 90 triangle is another special triangle we could look into. Since both of these angles are 45 degrees, the side lengths are equal, so this side is 1 and so is this one. If we use the Pythagorean theorem again, we can solve for the hypotenuse, which ends up being the square root of 2. Using sine, we see that sine of 45 degrees is equal to 1 over the square root of 2. If we multiply the fraction by the square root of 2 over the square root of 2, we can rationalize this denominator, and we get the square root of 2 over 2. It's the same deal for cosine, which is actually pretty neat. We use degrees a lot to express angles, but to be honest, it seems a bit random. Instead of this, let's define a better way to express angles. Radians are angles that are derived from the radius. To get this angle, we draw a circle with some radius. Let's mark this point that connects the radius to the circumference. Now, let's travel this exact distance from the radius along the circle. If we connect another radius to that point, the resulting angle is exactly 1 radian. Let's find out how many radians are in a circle. Since the arc length of this section here is equal to the radius's length, r, we can set up a fraction that deals with the circumference. Recall that 2 pi r is our circumference, all along the circle. The fraction that the arc takes up out of the whole circle is r out of 2 pi r radians. We can cancel out the r's, and we see that the arc length from 1 radian takes up 1 out of 2 pi of the whole circle. So that means 2 pi radians would be the full circle. Further, let's look at the relationship between radians and degrees. If there are 2 pi radians in one circle, and also 360 degrees, we can set this equal to each other. Solving for 1 radian, we get 360 degrees over 2 pi, or 180 degrees over pi. Solving the other way, we get 2 pi over 360 radians, or pi over 180 radians. Okay, let's bring this all together. Say we put a coordinate plane down and have a circle with a radius of 1 centered at the origin. Automatically, we can place down these coordinates as our endpoints. But what about these points? They seem like a lot, but they're not placed down randomly. We actually do know exactly what these points are. With the help of trigonometry, we can find out exactly the value of these points. Let's look here, for example. This point is connected to this radius. The length of this radius is 1, and we can make a right triangle here. This point has a specific angle of 45 degrees or pi over 4 radians, opening from the x-axis. Recall that sine of an angle is equal to the opposite over the hypotenuse. So sine of 45 degrees, this vertical component, would be achieved if we solve for the opposite side. Sine of 45 degrees is equal to our opposite side divided by 1. So the opposite side, sine of pi over 4, is equal to the square root of 2 over 2. We also know this is the same for cosine, so the exact coordinates here are square root of 2 over 2, comma, square root of 2 over 2. Let's move our radius right here, with the angle of 60 degrees or pi over 3 radians. If we do the same process, we can find that our vertical component, sine of pi over 3, is equal to the square root of 3 over 2, and our horizontal component, cosine of pi over 3, is equal to 1/2. We can also do this for pi over 6 or 30 degrees. What about the other dots though? Well, note that these other dots are simply reflected across the y-axis, so our x values are now negative. In order, they are 120 degrees from the x-axis, 135 degrees, and 150 degrees. These other angles are in the third quadrant, so the x and y values are negative. These angles are 210 degrees, 225 degrees, and 240 degrees. The fourth quadrant has negative y values but positive x values. So, in order, our degrees go 300 degrees, 315 degrees, and 330 degrees. Note that our vertical component, or y value, in the unit circle is always achieved by the sine operation, and our horizontal component, or x value, is achieved through the cosine operation. This won't always be the case in other realms of mathematics.